Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at acid, bases, and salts. And our subtopic for today is fractional crystallization. So we will discuss what fractional crystallization is, and then also do a few questions that relates to fractional crystallization. So one of the uses of solubility curves is to identify the mass of crystals that would be obtained if we cool that saturated solution. It also helps us to separate substances, and one of the ways is fractional crystallization or recrystallization, and that is what we are going to do today. And it helps us to separate salts from mixtures of salts in differing solubilities. For example, in the extraction of trona, we know this is the principle that it's used. So we know that in extraction of trona, we have trona and sodium chloride that are usually mixed, and they're usually separated differently depending on how they crystallize during in different temperatures. It also helps in the manufacture of certain salts like in sodium carbonate bisolvate process. You also know that we form ammonium chloride and sodium carbonate, which crystallize in different temperatures. That's why we are able to separate sodium carbonate, from sodium hydrogen carbonate from ammonium chloride. So let's look at fractional crystallization. So what fractional crystallization is? It's the physical method of separating mixtures of solute with different solubility in a particular solvent. So we have a mixture, and then from that mixture, we are able to use the fact that they are soluble in different temperatures to separate them. So when a substance to be separated are in solution form, the solution is cooled where the substance of low solubility is obtained as the first fraction when it crystallizes, and then the other substance of higher solubility is obtained as the second fraction when it crystallizes on further cooling. So for example, let us look at the table below. So we have potassium nitrate and potassium chlorate. So when you look at their solubility, potassium nitrate dissolves 90 grams at 50 degrees Celsius, and then 30 grams at 20 degrees Celsius. So you can see the solubility is decreasing. And then for potassium chlorate, it dissolves at 20 grams at 50 degrees Celsius and 6 grams at 20 degrees Celsius. So you can see also the solubility is decreasing, but you can see they dissolve at different masses, dissolve at different temperatures. So what happens when the two salts are dissolved in water, then cooled from 50 degrees Celsius to 20? So let's do the math. So first of all, we'll start with 50. So at 50 degrees Celsius, uh, so potassium nitrate dissolves 90 grams, and then potassium chloride dissolves 20 grams. So we are starting from 50 degrees Celsius. We dissolve these two salts at 50 degrees Celsius. So both of them, we have 90 grams of potassium nitrate and 90 grams of potassium chlorate. They have all been mixed in a beaker at these temperatures. So when we put the beaker aside and it starts cooling, it cools from 50 to 20 degrees Celsius. So we need to identify if there is any crystals that are going to form. So basically we are going to look at each salt, how it's going to behave at 20 degrees Celsius. So for potassium nitrate, it initially had 90 grams in solution. So at 20 degrees Celsius, it can only dissolve 30 grams. This is at 20 degrees Celsius. This tells you that there is a certain amount of salt that has crystallized out. And the one that has crystallized out will be 90 grams minus 30 grams, which will give you 60 grams. So 60 grams of potassium nitrate crystallizes out. And then also we notice at 20 degrees Celsius for the potassium chloride, only 6 grams is able to dissolve, but we started with 20 grams. That tells you if you subtract 20 minus 6 grams, you get 14 grams of potassium chloride that will also crystallize out. So if we were to measure the total mass that crystallized out, we would say it is 60 plus 14, that is for the mixture, which will give us 74 grams of the mixture. And that's how you are able to use a fractional crystallization with different temperatures. Let's do another question. The table below gives the solubilities of substance T and U at 10 degrees Celsius and at 40 degrees Celsius. So you have substance T, which at 10 degrees Celsius dissolves 40 grams in 100 grams of water, and at 40 degrees it's 65 grams at 100. And then U, which dissolves 15 grams in 100 grams of water and 17 grams in 100 grams of water. So when an aqueous mixture contain, so we have the actual uh, salt or the actual mixture, and also this is the theoretical. So we use the actual to use the theoretical to solve the actual. So actually, when an aqueous mixture of 55 grams of tea, so we have 55 grams of tea and 12 grams of U at 40 degrees, supposed to be 40, at 40 degrees Celsius was cooled to 20 degrees Celsius. Crystals formed. Identify the crystals. So let do the calculation. So we start at 40 degrees Celsius. So theoretically, the value of T is supposed to dissolve 65 grams, and we have 55. So actual is 55 grams, and at 10 degrees Celsius it only can be able to dissolve 40. So we started with 55, it can dissolve at 65, so at 40 degrees all of 55 are dissolved, but as we cool at 10 degrees it can only dissolve 40 grams. This tells you not the whole 55 will still be dissolved. Some of them is going to crystallize out, so it's going to be 55 grams minus 40 grams, which gives us 15 grams. And then for you, at 40 degrees Celsius, it's able to dissolve 17 grams. And actually, we had 12 grams. That tells you at 40, all of it will be soluble. At 10 degrees Celsius, it's able to dissolve 15 grams. So you see, still even at when we cool, all of it will be soluble. So the first question is determine the mass of identify the crystals. So we form crystals of T. Determine the mass of the crystals formed. We have already calculated. It's going to be the 15 grams. And then name the method. The method is called fractional crystallization. Let's do one more last question. Study the information in the table below and answer the questions that follow. So we have copper sulfate and lead nitrate. Copper sulfate dissolves 28 grams at 40 degrees Celsius and 38 at 60 degrees Celsius. Lead nitrate dissolves 79 grams at 40 degrees Celsius and 98 grams at 60 degrees Celsius. So we can note down that at 40 degrees Celsius, let's see the questions that you can know what to start with. A mixture containing 35 grams, so this is the actual copper sulfate, and 78 grams of lead nitrate in 100 grams of water at 60 degrees was cooled to 40. So let's start at 60 degrees. So for the copper sulfate at 60 degrees, it dissolves 38 grams, and the actual was 35 grams. So at 60 degrees, all of it had dissolved. So when it was cooled to 40 degrees Celsius, we know at 40 degrees Celsius, it's able to dissolve only 28 grams. But we have 35, so it means some of it crystallized out. So it's going to be 35 minus 28 grams, which will give us 7 grams. And then lead nitrate at 60 degrees Celsius, it dissolves 98 grams, but the actual that we had was 78 grams. So it means at 60, all of it had dissolved. But at 40 degrees Celsius, it's able to dissolve 79 grams. This tells you even if we cool, still all of the 78 will be soluble. So there is no crystals that were formed. So what salt crystallized out? So you say it's the copper sulfate because only 38 grams of the salt can dissolve at only 28, it's not that 28 at 40 degrees Celsius. And then how much of it crystallized out? So we have already calculated, which we have noted 87 grams. So that's it. That brings us to the end of salt solubility. So I hope you have been able to understand how fractional crystallization works. You can also be told to mix these two salts and you asked questions, graphical questions, which we have done in the previous lesson. You can see how we drew the graph. So, and be able to do more questions as well. So that's it for today. See you in the next lesson.